Hello, welcome back to our e-learning session, and this is your 10th lecture of chapter number 5. See, in our last session we complete your all the illustration, that is illustration 17 as well as your ABCD 4 section exercise 5 section ABCD all sections short sums, and your doubts we will discuss in our last session. We discussed that. Okay, now I told you that you have to do section E and F in your homework. Now in this session some students told me about their doubts of section E and F some sums, and I am now discussing their doubts as well as the new point whatever is there in section E and F. I am explaining you here on the board in this lecture. Okay, so here we will start our next point, that is your doubts of section E and F and just different explanations. Section E 1 to 5 are the theory questions. Now section E question number 6. See that here the point is, first of all I am reading the question. Various measures for the frequency distribution of monthly salary of two production firms are as follows. Compare, underline this particular word, compare the firms using coefficient of skewness by Bowley's and Carl Pearson method. See, in our last session I told you that illustration number 17 is our last illustration and 18 illustration is also there, but government cancelled the comparison in our syllabus. Government cancelled the comparison of Bowley's and Carl Pearson method. That is, last topic is cancelled by the government, and that's why that we will discuss in our regular session in our school. That's why at that time I am skipping that, as well as here this sum question number 6 we have to skip here. That we will discuss in our regular session, so please cancel it right now. Okay, so cancel 6th question, then 7th one. See the question, I am reading the question first. The frequency distribution of the sale of notebook from the stationery shop in the month of the June for the year 2014 is as follows. Find the coefficient of skewness using Carl Pearson method. Here specifically say that you have to find out the coefficient of skewness using Carl Pearson method. But see that the question 30, 25, 21, the data is given, it's a discrete group data, and the 2, 2, 7, 3, 4, 7, 2, 3, that is the frequency is given. So 7 highest frequency is 2 times. That's why here we can say mode is ill-defined. That's why we have to use the second formula, that is through median we have to find out Carl Pearson coefficient of skewness. Okay, so here nothing new in the 7th question, just Z, that is mode is ill-defined, and you have to find out the median and then find out the coefficient of skewness by Carl Pearson method by using second formula. Next point, 8th, next sum. See, it is very easy, that's why I am not doing on the board, that we already discussed in our previous sessions. That's why. Now next, and other, if you have any further doubts in this session, in these sections, section EF or any of the other sections, then please ask me in our Zoom lecture. We will discuss your doubts as well as solve your doubts in our Zoom lecture. 8th question. The following information is available about the defective staplers after testing 50 packets of the 500 staplers each. Find coefficient of skewness using Carl Pearson method. Again, simple sum. Carl Pearson method we have to use for the finding out coefficient of skewness. Here the data is given 19, 20, 21, 23, again the discrete group data, and the highest frequency. See, the highest frequency is what? It is 18. So mode is defined? No, because mode is in the starting. See, if the highest frequency is in the starting or at the end of the data, not in the center of the data, then you can also say that is the next point. See, we already see in our fourth chapter, that is in the third chapter, mode is ill-defined. For that 5 situations is given. if that 5 situation is there, then you can say mode is ill-defined. But here the next 6 situation is we already discussed in our 5th chapter, that is if the highest frequency is not in the center, near about center, not exactly in the center but near about the center, then also you can say mode is ill-defined. Where the highest frequency is the 80 and it is in the second, it is for the second observation, right? So here after that 3, 4, 5, 6, 7 and 8, total 8 observations are there, and the highest frequency is on the second observations, not nearest to the center. That's why also we can say mode is ill-defined, and that's why we have to find out median, and through median we have to find out coefficient of skewness by Karl-Pearson method. That means here no specification is given. By seeing this sum, you always do the sum using Z, that is using mode method, because no any 5 situations are there. See, the data is not mixed group distribution. Here the highest frequencies comes once. Here class is not there because this is a discrete group data. That's why no situation is against the mode is ill-defined. But the extra one situation, that is if the highest frequency not nearest to the center, then also mode is ill-defined, and that's why we have to find out median in this sum. New for this only that you have to find out median, and through median you have to find out the coefficient of skewness. Okay, so please do this sum by yourself. Now you can do this. If you are doing the sums through mode, then your sum answer is wrong. Okay, so please do that. And the 9th sum, see the 9th sum, the sum style of the question is only change here, nothing else. See, in the sum n is equal to, what is the data given, that is n is equal to 200 sigma f x minus 240 is equal to 0. See, why this value is given? If the value is 0, then why it is given? What is the use of this value? See, x minus x bar in our 3rd chapter and also in our 4th chapter, I told you sigma x minus x bar is equal to always 0, always, right? So here f, and also f into x minus x bar is 0, then f into x minus x bar is also 0. So here if sigma f into x minus x bar is equal to 0, that means here this one is your x bar. So from this data you can say x bar is equal to 240. Therefore we can say x bar is equal to 240. On the basis of this we can say this: sigma f x minus 240 is equal to 0. That means this is sigma f x minus x bar, because it is always 0. That's why x bar is equal to 240. Okay, now the second thing is given, that is sigma f x minus 240 whole square is equal to 11,250, right? Okay, and the last thing given is median. Median is equal to 246. See, x bar is there, now median is there. Now you have to find out if coefficient of skewness, that is J, by using Karl-Pearson method, because x bar and median is there. That's why you have to use Karl-Pearson method. And Karl-Pearson method, what is the formula? X bar minus m upon s. X bar is there, yes. M is there, yes. But we have to find out s. On the basis of these information, you have to find out the standard deviation. Now, what is the formula for standard deviation? S is equal to into the square root sigma f x minus 240 whole square upon n. This is the formula. And on the basis of this, 11,250 divided by 200. Now simplify it and find out the value of s. divide, then square root, that is your value of S. Now you have X bar, then M, and then S. Now you can find out the coefficient of skewness by using Carl-Pearson's method. So see the question. For the frequency distribution of the set of these data, find the coefficient of skewness and state the types of skewness. Find the coefficient of skewness. By which method? No specification, but X bar and median is given. Then you can understand that you have to find out the Carl-Pearson's coefficient of skewness compulsory, because these two data is here, and from this information you have to find out S and then find out Carl-Pearson's coefficient of skewness by median method. Yes, and you have to also state the type of the skewness. It is positive or negative. You have to write down that also. That contains 1 mark. See, this is 5 mark sum, but if you are not writing out the positive skewness or negative skewness, that is the final decision. Is if you are not writing out in one line, then your 1 mark is cut here. Whenever they ask about the types of the skewness, then you have to write down 1 line for that, for the final answer, that is a positive skewness or it is a negative skewness. Okay, so here your section E is over. All the sums of section E. Now first 2 5 theory, 6 cancel for right now only, then 7 8 easy, but only you have to use the Carl-Pearson's method, but median method, not mode method, right? And in the last sum, the twist is this, and I'm clear your twist, your doubts. So here section E is over. Now the section F. In the section F, most of the sums are twisted. So we have to discuss about that. First question, section F, question number 1. The frequency distribution of the number of accidents due to driving for more than the prescribed time is given below. Find the coefficient of skewness by Bowley's method. Here we have to find out the Carl-Pearson. No. Here we have to find out Bowley's method. Coefficient of skewness by using Bowley's method. So what we have to find out? Q1, Q2, that is median, and Q3. Okay. For that, what we have to find out? First, we have to arrange the data in ascending order if it is not given. See here, the data is given, it's discrete group data. But the data is given in the descending order, not in the ascending order. So first we have to arrange the data in the ascending order, and then we can find out Q1, Q2 and Q3. I am doing that. See here. Number of driving was more than prescribed time. And the number of accidents. See, the data is given 4, 3.5, 3, 2.5, 2, 1.5, 1 and 0. It is given into the descending order, but we have to arrange in the ascending order. So 0, 1, 1.5, 2, 2.5, 3, 3.5 and 4. And corresponding frequency we have to also adjust. We cannot write down. If we change the original, that is X, all the observations order is changed, then the frequency of that particular corresponding frequency we have to write down here. What is the corresponding frequency of 0? See, the frequency of 0 is equal to 1, that we have to write down here. F is equal to 1 first. Not we cannot write down 5, 4, 3 as it is, but 0. What is the frequency of 0? That is 1. What is the frequency of 1? That is 2. Again, what is the frequency of 1.5? That is 2. Now 1. Then 2, 3, 4, 5. And then CF, cumulative frequency 1, 3, 5, 6, 8, 11, 15 and 20. So n is equal to 20. So this is the original question now. Only in this question the twist is there. You have to find out the coefficient of skewness first of all by Bowley's method. For Bowley's method you have to find out Q1, Q2 and Q3. And to find out Q1, Q2 and Q3 you have to arrange the data in ascending order like this. As well as the corresponding frequency we have to arrange. Then find out cumulative frequency and then it is now easy. Q1, Q2 and Q3. See that Q1 is equal to what? N plus 1 by 4th observation. That is 20 plus 1 by 4th observation. That is 21 by 4th observation. That is 5.25. See here, corresponding observation is 2 because see into the frequency, cumulative frequency 6 is there. For 5.25 lies between 5 and 6. That's why here the corresponding observation, that is Q1, is equal to 2 hours. Now Q2, that is n plus 1 by 2th observation, that is 20 plus 1 by 2th observation, that is 21 by 2th observation, that is 10.5th observation. And see in the cumulative frequency column, 10 is here after 8 before 11. So 10.5, that's why corresponding value of n is equal to 3 hours. Here Q1 is equal to 2 hours, m is equal to 3 hours, and the last is Q3, that is 3 into bracket n plus 1 by 4th observation, that is 3 into bracket 20 plus 1 by 4th observation, that is 3 into 21, that is 63 by 4th observation, that is 15.75 fifth observation. And C in the cumulative frequency 15.75 is lies here. So the corresponding observation is 4. That's why we can write here 4 hours. Q3 is equal to 4 hours. Now see the distance. Why I am doing this? Because see, you all know about this. Q1, Q2 and Q3 we already practiced for more than 5 to 10 sums for this. So I think that you already know about this, but the new thing is right now. See here, the difference between these two and the difference between these two is equal here. Q3 minus M, 1. M minus Q1, 1. If the difference, see the properties, remember the properties that if the difference between two quartiles, that is Q3 and Q2, Q3 minus Q2 is equal to Q2 minus Q1, difference is equal, then you can say that here your coefficient of skewness or skewness is equal to 0. That means it's a symmetric distribution. Skewness where the difference is greater than or more than, then it is called a negative or positive skewness. Yes, but if the difference is equal between two quartiles Q1 and Q2 or Q2 and Q3 are equal, then it is said that it is a symmetric distribution. We already discussed about that in our first session of this chapter, chapter number 5, right? So here the skewness is 0. How? We can say J is equal to, we can apply the formula Q1 plus Q2, Q3 plus Q1 divided minus 2m divided by Q3 minus Q1. What is Q3? That is 4. What is Q1? That is 2 minus 2 into m is equal to 3 divided by 4 minus 2. That is 6 minus 6 divided by 2 or 0 by 2. That means here we can say J is equal to 0. The coefficient of skewness is equal to 0 because the difference between quartile and median is equal. Okay, so here don't be panic about that. If your answer is 0, you are wrong. No, you are right, because here the data is given, it's a symmetric group distribution, and that's why symmetric distribution is if given, then you can say your skewness is always 0. So you are using your properties of coefficient of skewness. Okay, complete. This sum is over. Section F. This one is the section F, question number 1. So first of all, write down these. Then we will discuss about your next doubts. Please write down these first. Now, write down this. We will discuss our next point, that is sum number 2. The daily temperature of the city in the year 2014 is recorded as follows. The daily temperature has not been below minus 10 Celsius. Right? So here the data is again given in a different style. If you know about the chapter number 3, then you can solve this sum. Otherwise you cannot solve this sum, because here the mid value is given, regular main data is not given, continuous group data is there, and the class is not given here. Here the third step, that is third column, mid value, what we are finding out, that is given. We have to first of all find out the original question on the basis of this, and then you can find out the coefficient of skewness and other things, whatever they ask. But first of all, here the question is not given. Here the part of the answer, see, not answer also, part of the answer, that is mid value and the frequency. First class, then frequency, then we are finding out the mid value to find out x bar and to find out s, that is standard deviation. We are finding out the mid value. Here the mid value as well as frequency is given, class is not given, and on the basis of only mid value we cannot find out the further x bar, median as well as the standard deviation we cannot find out. So if you want to find out the median as well as mean as well as standard deviation, you have to first find out the original class, that is original question, and then you can find out the remaining items, that is main item is coefficient of skewness. Then you can find out that. But here we have to find out first the original class. How? That we are discussing. See that on the board, that we already discussed this type of sum in chapter number 3. See, the lower class boundary, first of all, what is the given is lower class boundary. that is given minus 10 Celsius. Okay, now the mid value. All the mid values are given, but we are writing out mid value 1, mid value 2, mid value 3 and so on. So your first mid value is equal to minus 5. Okay. These two data is given. On the basis of that, first of all we have to find out the class, original class. See the original class. Daily temperature of a city in Celsius. Here we have to write down the original class. But for that we have to first of all find out the lower class boundary is given. Here we have to find out the upper class boundary, and before that we have to find out the class interval. And for that, see here, what is the formula for lower class boundary? Lower class boundary, that is LCB. I am writing in the short form. Lower class boundary is equal to mid value minus C by 2. C means class length or class interval, right? This is the formula. Now we have what? Lower class boundary of first class, yes. Mid value of first class, yes. We don't have class interval or class length. So on the basis of these two, we can find out class length or class interval, yes. Therefore we can say lower class boundary is minus 10 is equal to mid value is equal to minus 5 minus C by 2. So here I am transferring all these on this side and these on this side. So minus C by 2 is transfer on this side, that's why plus C by 2, minus 5 as it is, 10 transfer on the opposite side of is equal to, that's why plus. Therefore we can say C by 2 is equal to 5, and therefore here 2 is divided. So if we want to transfer these 2 on the opposite side, we have to multiply it. C is equal to 5 into 2, that's why C is equal to 10. Yes, we are finding out the class length. See, the class length of each and every class is different here. How we know that? See the mid values. All the mid values are not in equal distance. If all the mid values are in equal distance, then we can say all the class length or all the class intervals are equal. See the mid value, first mid value is minus 5. Then second mid value is 5. That means difference between two is 10. Then 5 to 12, that is difference is 7. Then 12 to 18, difference is 6. And then 18 to 25, that means difference is again 7. Okay, so here in each and every mid value, the difference are unequal, and that's why we can say the class length of each and every class is also not equal. So we have to find out all the class by using this formula. First of all, we are finding out class length from this, and then upper class boundary. Upper class boundary, what is the formula for that? Mid value plus C by 2. Mid value minus C by 2, that is lower class boundary. Mid value plus C by 2, that is upper class boundary. Now we have mid value for this, that is minus 5. Class length for this, yes, 10 by 2. So here minus 5 plus 5, that is 0. So your first class for this data is minus 10 to 0, because the first class lower class boundary is minus 10 and the upper class boundary is 0. So we can write here minus 10 Celsius to 0 Celsius. This is the first class. Now on the basis, see, always this is inclusive or exclusive type of data, but here no specification is given, then you have to assume that this one is the exclusive type of data. So the upper class boundary of first class is the lower class boundary of the second class, compulsory. So here we can write that 0 Celsius for the next class, and for the next class 0 Celsius is lower class boundary, then we can write here also lower class boundary of second class is 0. your mid value, second mid value. What is your second mid value? 5. Your second mid value is 5. So now on the basis of these two, again this formula we have to apply to find out C, as well as this formula we have to apply to find out upper class boundary. So here see that again using this formula we are finding out the next mid value as well as next class length as well as upper class boundary. Lower class boundary for this data is 0. See, the 0 is not minus or plus, therefore 0 is equal to mid value is 5 minus C by 2. Yes, so here minus C by 2 convert on this side, that's why plus C by 2, 0 as it is, 5 minus 0, 5, 0 transfer on this side, minus 5 minus 0, that is 5, and C by 2 transfer on this side, that's why minus become plus. So here C is equal to 2 into 5, again C is equal to 10. Class length for this data is also 10. Now upper class boundary, mid value, again what is the mid value? 5 plus C, that is 10 by 2. So 5 plus 5, so 10. Okay, so lower class boundary is 0 Celsius, yes 0, and the upper class boundary is 10 Celsius. So here the second class is also there. We are finding out the second class. Again the second class, here we can say the upper class boundary of second class is the lower class boundary of the third class. So here we can say third class lower class boundary is equal to 10 Celsius. Now what is the new mid value? Third mid value is equal to 12. Third mid value 12. See, repeat this. We have to, in each and every class we have to find out the class length, because the class length is not equal, and on the basis of class length we have to find out the upper class boundary. Again lower class boundary is equal to 10, mid value is equal to 12 minus C by 2. Therefore C by 2 transfer on this side, C by 2 is equal to 12 minus 10 transfer on this side, minus, that's why C by 2 is equal to 2, that's why C is equal to 2 into 2, that's why C is equal to 4. Right? Easy. Now this C we are using here, mid value again 12 plus C is equal to 4 by 2, that is 12 plus 2, that is 14. Your upper class boundary is 14 and your lower class boundary is 10 Celsius. So your third class is here 14 Celsius. Right? Now this is also, we can write here 14 Celsius is the next class lower class boundary. Next fourth class mid value is 18. Just follow this method, nothing else, no new is there. Just follow this only. So here lower class boundary is 14, mid value is 18, C by 2, again same procedure, 18 minus 14, C by 2 is equal to 4, C is equal to 4 into 2, therefore C is equal to 8. We are using these also here, mid value 18, 8 is the class length, 18 plus 4, 22. Here lower class boundary is 14 Celsius and the upper class boundary is 22 Celsius. This is not a sign of minus. This is dash, this to this, this to this, this to this and this to this. 14 Celsius to 22 Celsius. So the next, again the next class lower class boundary is 22 Celsius. Okay. And the lower class boundary after that, mid value, fifth mid value 25. Repeat this procedure. Find out the next class length as well as upper class boundary. Lower class boundary is 22, mid value is 25 minus c by 2. C by 2 is equal to 25 minus 22. C by 2 is equal to 3. C is equal to 3 into 2. C is equal to 6. Mid value again 25. 6 by 2, 25 plus 3, 28. Your last class is 22 to 28 Celsius. See, this is the main point. This is the main difficulty from your side. That is, you have to find out first of all the original class, and by using these two formula only and these two values, we can find out all the class. That is, this one is your class, that is original question. Now on the basis of this and the frequency given, see the frequency given, number of days, first 25, then 35, then 105, then 125, and then 75. Again, mode is ill-defined because the class length of this class is unequal. Here the class length is 10, here the class length is 10, here the class length is 4, here the class length is 8, and here the class length is 6. So the class length of each and every class is unequal. That's why we can say mode is ill-defined. That's why from this we have to find out median, from this we have to find out x bar, that is mean, and from this we have to find out standard deviation. So I hope now it is very easy. The main point of doubt from your side is this: what is the original question? This one is the original class. Now on the basis of that, you can find out mean, median, and standard deviation, and then you can find out the Karl Pearson coefficient of skewness. So now it's up to you. Now you have to do this sum, but first of all write down this full, all the class, all the observations, and then find out mean, median, and standard deviation, and then coefficient of skewness. So here your exercise 5 section F question number 2 twist is completed here. The remaining sum you have to do in your homework. And now we are discussing our third question. The distribution of the marks obtained by the 60 students in the examination is as follows. You find the coefficient of skewness by Karl Pearson method and state the types of skewness. Easy question, 0 to 10, 10 to 20, 20 to 30, and normal question is given. Frequency is also highest, 2 times, 38, 38. Again, mode is ill-defined because 2 times highest frequency is given. That's why we have to find out through median, Karl Pearson coefficient of skewness. Okay, so it is easy. So there is no doubt from your side. That's why I'm not doing that sum. Only you have to find out the median from these and then find out the Karl Pearson coefficient of skewness. Okay, then fourth sum. See, again the new thing is that the frequency distribution of the profit earned by the 150 companies during the year 2015-16 is as follows. Find the coefficient of skewness using an appropriate method. Underline that particular word, appropriate method. See, for that, the Bowley's method formula after illustration number 12. Sorry, before illustration number 12, Bowley's method. See, after in the Bowley's method, all the formula, after all the formulas, one note, 2 notes is given. I am reading that particular note on page number 197. Note first, after Bowley's method, first, if the frequency distribution is open-ended, underline this word. If it is open-ended, this is only the method to find out the absolute or relative measures of skewness. What means of that here? If you want to find out the open-ended class skewness, then you have to use compulsory Bowley's method. Why? At that time I also explained that, and here right now I am also again explaining you that if your class, see the class less than 10 and the last is 40 and above, what is the mid value? If you want to find out the coefficient of skewness by Carl-Pearson method in this sum, then you have to find out first of all x bar. X bar is means what? For x bar we have to find out the mid value. So less than 10. What is the mid value of less than 10? Less than 10 means what? 0 to 10, minus 10 to 10, minus 20 to 10. What is that? No any starting point is given here. So we cannot write down the mid value of first class. Then we can find out 10 to 20. Yes, 10 plus 20 divided by 2, that is 15. 20 to 30 divided by 2, 20 plus 30 divided by 2, that is 25. So the mid value of 10 to 20, 20 to 30 and 30 to 40 is there. But first class mid value we cannot find out, and as well as the 40 and above last class. What is the mid value of 40 and above? 40 to 50, 40 to 60, 40 to 70. What is that? That we don't know. So we cannot find out the mid value of first class as well as the last class. That is called open-ended class. Okay, and whenever the open-ended distribution is given, then you cannot find out the x bar as well as s, standard deviation. And if you don't find out the x bar and s, you cannot find out, you cannot use the Carl-Pearson coefficient of skewness method. At that time, compulsory you have to use the Bowley's method. On the basis of this, you can find out Q1, Q2, that is median, and Q3. So here, no more extra explanation is there. You just have to, whatever the word is there, using an appropriate method. Here the appropriate method is Bowley's method, nothing else. Now the sum is normal. You have to use which method I want to explain you, and here I am explaining you that you have to find out the coefficient of skewness in this sum by Bowley's method. Okay, so find out by Bowley's method Q1, Q2 and Q3, then coefficient of skewness, that is J. Now the fifth one. The frequency distribution of the demand of a certain items is as follows. Find the skewness and coefficient of skewness by Carl-Pearson method. Seriously, again, it is definitely given that you have to use the Carl-Pearson method, and again, mixed distribution is given, so you can say that mode is ill-defined. So you have to find out median, and through median you can find out Carl-Pearson coefficient of skewness, and that's type of sum we already discussed in our examples. That's why that is not new for you. That's why I hope you complete that. That is depends on you. Now you have to do that this sum. So 1 to 5 sum is over. Now the next sum, important sum, and the main thing, new extra thing given in the sixth sum, and also from your side 1 or 2 students asked me about this sum. I am reading this sum. See, a sample of 50 screws was taken from the lots of the screws produced at a factory to measure the diameter in mm of head of each screw, and its frequency distribution is as follows. Find the Bowley's coefficient. Here we have to use the Bowley's coefficient of skewness. That's why Q1, Q2 and Q3 you have to find out. Data is given in a different style. Okay, see the data. Question number 6. See, diameters of head of screw is given. See, the data is given like this. And number of screws 4 to 4.1, then again 4 to 4.2, 4 to 4.3, 4 to 4.4, 4 to 4.5, 4 to 4.6, 4 to 4.7 and 4 to 4.8. And the frequency 6, then 13, 23, 33, 41, 46, 48 and 50. See, the question is given like this, but this is not your original question, because in the question the sum is, when the class is given, it is only on the basis of two values. Why? How? See, inclusive type of data or exclusive type of continuous group data is only given, but here this is not an inclusive type as well as not an exclusive type of data. This is a less than or more than type data. Here 4 to 4.1, then the next class compulsory is 4.1 to 4.2, then next class is 4.2 to 4.3. If exclusive type of data is given, then here the lower class boundary is 4.2, here 4.3, here 4.3, here 4.4, here 4.5 and so on. But it is not given. So first of all, this is not your original question. First you have to find out your original question or write down your original question. I am writing out that diameter of head of screws in mm, that is 4 to 4.1. Now 4.1 to 4.2, 4.2 to 4.3, 4.3 to 4.4, 4.4 to 4.5, 4.5 to 4.6, 4.6 to 4.7 and 4.7 to 4.8. This is the original class, compulsory. And if this one is the original class, then this is not your frequency. Your frequency, number of screws, that is also, this is, you can say, less than or more than type question, but you have to find out the original frequency. See the frequency, you can say not by seeing this, you can say by seeing this also. This is not an original frequency. 6, then 13, then 23, then 33. Thus frequency is increasing, and whenever the frequency is increasing, it is not a frequency, it's a cumulative frequency. Okay, it's a cumulative frequency. And see, if I told you at that time less than, you have to subtract second minus first, and in the more than, first minus second. But you have to, don't remember that thing, you have to just remember that positive, always the frequency is positive. So if you are subtracting 6 minus 13, then the answer is negative. So you have to subtract 13 minus 6, 23 minus 13, 33 minus 23. Always the frequency is positive. Yes, you have to remember only one thing. So see the frequency, if the frequency is highest in first and lowest in the second, then first minus second, and second is highest and first is lowest, then second minus first. Just remember only that frequency is only positive. So second minus first, third minus second, fourth minus third, that is the procedure I am writing here. 13 minus 6, sorry, first of all not 13 minus 6, 6 minus 0. 6 minus the previous class frequency, that is no frequency, that's why 6. 13 minus 6, 7. 23 minus 13, 10. 33 minus 23, 10. 41 minus 33, 8. 46 minus 41, 5. 48 minus 46, 2. And the 50 minus 48, again 2, is the frequency. See, you have to write these only. This is just for your knowledge. Please don't write this type of frequency in your answer. This is, you can do this in your working note, yes, but you cannot write down this because this is your original and this is your, see, 6, 7, 10, 10, 8, 5, 2 and 2. This is your original frequency. Okay, so you have to write down these and then find out the CF, because you have to find out the Pauli's method coefficient of skewness, and CF you don't have to find out CF because CF already given here. You just have to copy that. And your N is equal to 50. So this is your original question, and on the basis of that you can find out Q1, Q2 and Q3. The twist is only this. So now you can see, you can find out your remaining question, that is coefficient of skewness Q1, Q2 and Q3, and then coefficient of skewness by using Pauli's method. Only this is the new one. That already we discussed already that point in our third and fourth chapter, but I hope you forget that. That's why I am doing here that point. So here your sixth question of exercise 5 section F is also over. I hope you complete this sum in your homework. Okay, now the seventh one. Sixth, after that, seventh, from the following frequency distribution of daily sales of packets of bread for the departmental store, find the coefficient of skewness by Carl-Pearson method and interpret it. Here we have to use the Carl-Pearson method. See the data first. 0 to 3, then 3 to 5. What is the frequency class length? 0 to 3, that is 3 class length. 3 to 5, 2 class length. 5 to 10, 5 class length. 10 to 15, 5. 15 to 25, then 20 to 30, 10. Class length is 10. Then again 10, and then last 20. 40 to 60, that's why class length is 20. So here the different class interval, class length is given, and we have to use the Carl-Pearson method. Then we can say mode is ill-defined, and we have to find out median. So now it is easy. It is also not from your doubt. That's why here I hope you complete that. X bar minus m, 3 into bracket x bar minus m upon s, that is the formula for the Carl-Pearson coefficient of skewness. So 7th, you have to do this sum by median coefficient of skewness by Carl-Pearson method. Okay, now 8th one. See the new point. 8 is given here. The frequency distribution of the sales from the shop selling glass is as follows. Find the Pauli's coefficient of skewness and interpret it. New point. See the new point here. See which type of data is first of all given. Inclusive type of data or exclusive type of data? It's inclusive type of data. The question I am writing here: 1 to 1.9, 2 to 2.9, 3 to 3.9, 4 to 4.9, 5 to 5.9, 6 to 6.9, 7 to 7.9. Right? And the frequency is given. Okay, so what is the main thing here? The class is inclusive type, right? See, the up to this, the class is given like this: 1 to 9, 10 to 19, 20 to 29, 30 to 39. Okay, inclusive type of data is given like this. And to find out median, here which method we have to use? Pauli. To find out Q1, Q2 and Q3. The formula is L plus N by 4 minus CF upon F into C. This is the class continuous group data. Formula for Q1, then L, then M, N by 2, then Q3, only 3 N by 4. The changes is only this point. Other thing is remaining same, right? But for this method, but for these sums, we have to find out L. How we find out L? In inclusive type of data. In inclusive type of data, if here 9 is there and here 10 is there, then what we are doing? 10 minus 9, that is what? 1 is the difference, divided by, this is 2 class, that's why divided by 2, that's why 0.5. See, I told you at that time that if, at the chapter number 3, whenever inclusive type of data is given, 9 is here and 10 is here, 19 is here and 20 is here, the difference between 2 class is 1, then it is 2 class different, that's why divided by 2, and 0.5, that 0.5 is subtracted from lower class boundary and added to upper class boundary, and your new class is 0.5 to 9.5, 9.5 to 19.5, 19.5 to 29.5, 29.5 to 39.5, and so on. Right? So, from inclusive type of data we are converting from exclusive type of data. This is the method we are using. Okay, but here the twist is there. Here the difference is not 1. Here the difference is 10 minus 9, that is 1, and 1 divided by 2, that's why 0.5. But the difference is here 2 minus 1.9. This minus this is equal to 0.1, and 0.1 divided by 2, that is 0.05. Here the difference is, the divided by 2, that is the value is 0.5. But here divided by 2, that is the value of 0.05. So here 0.05 is subtracted and 0.05 is added here. And you have to find out the new class like this. Or if you don't have to find out this, then while taking L, you have to just subtract 0.05 in from the class for lower class boundary. L is equal to what? In these and these cases, you have to subtract 0.05 from these. That's why here what is the value? 0.95, 1.95, 2.95, 3.95, 4.95, 5.95, and here 6.95. These are the starting value, and here these are the upper class boundary of this class. These are the lower class boundary and these are the upper class boundary, and from these now you can write take L is equal to whatever the corresponding value of n by 4 we have to see in the cumulative frequency column, and we have to take L from these, not from these. Okay, the twist in this sum is only here the difference is not 1, difference is 0.1. Up to all the sums the difference is 1, and that's why 1 by 2, that's why 0.5 we are subtracting and 0.5 we are adding. But here the difference is 0.1, that's why 0.05 is subtracting and 0.05 is added to find out the value of L, nothing else. So here in 8th question, only the taking L is the main doubt. Otherwise all the things are equal, all the values are equal, all the formulas are same. That's why we can now find out, you can now find out the remaining answers, that is Q1, Q2 and Q3 you can now find out easily. Only be careful while taking L in this formula. You have to take L from these. So please write down these, and your 8th sum is also over. And now see the 9th and 10th sum. 9th sum is normal sum. Discrete group data is given and you have to find out the Carl-Pearson method, coefficient of skewness. Here the mid value, the highest frequency 50 is also 1 is given. That's why here mode is defined. That's why you can use this mode formula, that is first formula of Carl-Pearson's coefficient of skewness. Very easy. Now you can find out that easily. And in the 10th sum, 10 to 15, 15 to 20, all the class length is equal, as well as the highest frequency also high 5, 10, 15, 20, 25 and 30. That's why you have to find out the Bowley's method. Directly question is given that you have to find out the Bowley's method, coefficient of skewness, find out Q1, Q2 and Q3 and then find out all the values. That is also the simple question. And also no doubt from your side, only the doubts whatever from your side, from the some students send me the doubts in WhatsApp. I am clearing their doubts here on the board. And if you have any further doubts in these skip sums or any other sums, previous sums, then please ask me in WhatsApp or please ask me in our Zoom lecture, because in our Zoom lecture we are discussing all your doubt sums. Okay, so please join the Zoom lecture. And here I am complete this chapter as well as this lecture here. Now we will discuss about the next chapter in our next session. Till that, till date I am complete my lecture. So thank you class. Bye bye. Have a nice day.